Hello and welcome. In our lesson today, we are going to go through a past KCSE question on extraction of lead metal. So stay tuned. So this question is from the year 2000, paper 2, and it goes as such. The flowchart below illustrates the industrial extraction of lead metal. Study it and answer the questions that follow. Now, before tackling the questions, let us go through the flowchart. So our origin is the ore. Now, lead has several ores, but the main ore from which lead is extracted is galena, which is lead 2 sulfide. So the ore is being fed into a roasting furnace. Now, when you talk about a roasting furnace, simply means a furnace where the ore will be heated in the presence of oxygen. Lead 2 sulfide reacts with oxygen to form lead 2 oxide plus sulfur 4 oxide. Now, looking at the roasting furnace, we can clearly see that sulfur 4 oxide is being produced. Now, sulfur 4 oxide is a pollutant, so that means that it cannot be allowed to escape into the surrounding. So what happens is that it's collected and it's either scrubbed, that is reacted with calcium hydroxide to form calcium sulfite, or it's collected and used for the manufacture of sulfuric acid through the contact process. Now, moving on to the smelting furnace. Now, as we can see, there are three different components that are being added onto it. We have iron, coke, and calcium oxide. Now, iron is simply scrap iron. Now, when we were discussing extraction of lead metal in the previous video, we talked about the role of scrap iron. Now, taking you back to the roasting furnace. So, in the roasting furnace, what happens is that most of the lead 2 sulfide reacts with oxygen to form lead 2 oxide, but some of it does not react. Now, the purpose of adding iron is simply to reduce any remaining lead 2 sulfide to lead metal. So there's our equation. So we have lead 2 sulfide being reduced by iron. Remember, iron is more reactive than lead to form lead metal plus iron 2 sulfide. So at this point, we should assume that all of the lead 2 sulfide has either been reduced to lead metal or to lead 2 oxide. Now, we also have another component, coke. Coke is carbon. So carbon acts as our reducing agent. So it reduces the lead 2 oxide to lead metal plus carbon 4 oxide. Now again, carbon is more reactive than lead and therefore is capable of reducing the lead 2 oxide. Last one, calcium oxide. Now, calcium oxide is obtained from calcium carbonate. So, calcium carbonate is the one that is fed into the furnace. On encountering the high temperatures within the furnace, it decomposes to form calcium oxide plus carbon 4 oxide. Now, calcium oxide plays a role in removal of impurities, specifically silica. Now, silica is silicon 4 oxide and it's one of the more common impurities that are found in metal ores. So, calcium oxide reacts with the silica to form a compound called calcium silicate. Now, this is removed as slag. Now, we can also see that in the smelting furnace, there's a gas P that is being evolved. And this, of course, is carbon 4 oxide. And then finally, we have the lead metal. Now, I believe we are ready to tackle the questions. So, A, Roman 1. Name the ore that is commonly used in this process, and this is galena. Roman 2. Explain what takes place in the roasting furnace. So, in the roasting furnace, what happens is that most of the lead 2 sulfide is roasted in air, causing it to react with oxygen to form lead 2 oxide and sulfur 4 oxide. Roman 3. Identify gas P. This is carbon 4 oxide. Roman 4. Write the equation for the main reaction that takes place in the smelting furnace. Now let's pause over here. Within the smelting furnace, there are actually several reactions that are taking place. So that means that we could come up with several equations for these. This is the one whereby lead 2 oxide is reduced by carbon to form lead metal plus carbon 4 oxide. Now, just a mention here, this reaction can lead to the evolution of carbon 4 oxide or carbon 2 oxide. Either of these equations are okay. Roman number 5. What is the purpose of adding iron in the smelting furnace? Now, iron reduces any unreacted lead 2 sulfide to lead metal. Roman number 6, give 2 environmental hazards likely to be associated with extraction of lead. First of all, there's sulfur 4 oxide, which we've discussed. Sulfur 4 oxide causes acid rain, which is very harmful to the environment. Number 2 is that lead can also cause lead poisoning. Last one, state one use of lead other than making of lead pipes. So lead has several uses, such as used in radioactive shielding. It's used in the manufacture of lead acid accumulators, making roofs, etc. So that, ladies and gentlemen, brings us to the end of our lesson for today. I hope it's been a fruitful one for you. See you next time.